students, today class AC circuit containing pure capacitor. Capacitor is a device storing for electric charge. Capacitor is an arrangement for storing electric charge. Capacitor consists of two parallel conductors separated a small distance with a dielectric medium. Now C is a capacitor. The capacitor of capacitance C connected in series with an AC source. Now the alternating voltage applied a pure capacitor. So this is a 3-mark question. Derive an expression for current in AC circuit containing pure capacitor when alternating voltage applied to the pure capacitor. Or one more type this question, show that current leads the voltage by an angle pi by 2 in AC circuit containing pure capacitor. So this is a 3-mark question. Derive an expression for current leads the voltage by an angle pi by 2 or 90 degree the AC circuit containing pure capacitor. So now a pure capacitor C is connected in series with an AC source. So in pure capacitor, the voltage and current are phase. So this is a voltage line. So already you know the definition of a phasor. Phasor is a vector rotating about in an anti-clockwise direction with a constant angular speed. So this is the voltage. Now this is the current line. The maximum value of phase represents peak value. So Vm is a peak value of alternating voltage. Im is a peak value of alternating current. So your voltage and current, how much angle difference is there? So 90 degree. 90 degree or pi by 2. Voltage and current, how vary with time in AC electrical circuit? The voltage vary like sine function with time. That is a sine wave or sinusoidal wave. This is a solid line. This solid line represents voltage line and dotted line represents current line. So the current vary with the sine function with time is called alternating current. So now we have two Vm and Im. Vm is a peak value of alternating voltage. Im is a peak value of alternating current. Now how much difference for phase difference of voltage and current in a pure capacitor? So here current line pi by 2, voltage pi. How much difference means 180 minus 90, so 90. So this is one more question. What is the phase difference between voltage and current in a pure capacitor? So pi by 2 are 90 degree. So pi by 2 current, voltage pi. How much difference is there? So pi minus 1 pi by 2, get pi by 2 or 90 degree. This is a one more question. The phase difference in voltage and current in a pure capacitor is pi by 2. So now we have a pure capacitor connected in series with an AC source. The AC source voltage V equal Vm sin omega t. AC source voltage V equal to Vm sin omega t, where V is a source voltage, Vm is a peak value of alternating voltage, omega is an angular frequency of AC. This sentence is very important, students. So V equal to Vm sin omega t. V is a source voltage, Vm is a peak value of AC or alternating voltage, omega is an angular frequency of AC. Now the pure capacitor connected to AC source, the alternating voltage passes to the pure capacitor. What happened? The capacitor gets charged. So Q is a Q be the charge on the capacitor. Q be the charge on the capacitor. Now from Kirchhoff's loop rule, from Kirchhoff's loop rule. From Kirchhoff's loop rule, voltage across the capacitor is equal to voltage across the source. So already you know the statement of Kirchhoff's loop rule. The algebraic sum of change in potential around any closed loop involving resistors and cells must be equal to 0. So potential difference across the capacitor equal to potential difference across the source. Now Vc equal to potential difference across the source what? Vm. So Vm sin omega t. Vm sin omega t. Now potential difference across the capacitor. So second unit a charge Q equal to C into V. So V equal to Q by C. The general formula Q equal to C into V. Potential across the capacitor V equal to Q by C. So now potential difference across the capacitor. Now take charge Q by C. Potential difference across the capacitor. So V equal to Q by C. Now we have mentioned here Vc equal to what? Q by C. Q is the charge at the capacitor. C is a capacitance of the capacitor. So Vm sin omega t. Now Q equal to the charge of the capacitor. Q equal to, so here C we multiply CVm sin omega t. So sin omega t. From Kirchhoff's loop rule, potential difference across the capacitor is equal to potential difference across the source. So Vc equal to Vm sin omega t. The potential difference across the capacitor V equal to Q by C is a general formula. Second unit electrostatic potential and capacitor lesson. Now Vc equal to Q by C. Q is a charge on the capacitor. C is a capacitance of the capacitor. Now Q equal to C Vm sin omega t. Now the current in the circuit. Now the current in the circuit. Now the current in the circuit I equal to dq by dt. Now the current in the circuit I equal to dq by dt. So I equal to dq by dt. Current symbol here I equal to d by dt. Q equal to what? C Vm sin omega t. Sin omega t. So differentiating. To apply differential calculus, differentiating with respect to t. So I equals C Vm constant d by dt differentiation sin omega t. Sin omega t. So sin omega t. Sin omega t. So now differentiation of sin omega t. So I equal to C Vm. So sin differentiation what? Cos. Sin theta differentiation of cos theta. Now sin 2 theta. Sin 2 theta differentiation 2 theta. The differentiation of sin 2 theta 2 cos 2 theta. Sin 2 theta differentiation 2 cos 2 theta. Now we have sin omega t differentiation. So omega cos omega t. So cos omega t. So I equal to Vm omega c cos omega t. Cos omega t. So I equal to Vm omega c cos omega t. But here voltage and current like vary with sign function with time. That is a sinusoidal wave or alternating current. So now convert cos to sine. Now you will convert cos to sine. So I equal to Vm. I equal to Vm omega c. So now convert cos to sine. Sine omega t plus pi by 2. Now your cos omega t is there, but voltage and current vary with the sine function with a time. Then you convert cos omega value of alternating voltage. So sin omega t plus pi by 2 plus pi by 2. Now this equation shows that I equal to Im sin omega t plus pi by 2. This equation shows that current leads the voltage by an angle pi by 2 in AC circuit containing pure capacitor. So in your question, derive an expression for current in a AC circuit containing pure capacitor when alternating voltage applied to a pure capacitor. Then I equal to Im sin omega t plus pi by 2. The above equation shows that current leads the voltage by an angle pi by 2 in AC circuit containing pure capacitor, where Im equal to what? Vm omega c. Now where Im equal to what? Vm omega c. Now this equation written as Im by Vm equals omega c. So Im by Vm equal to omega c. Now Vm by Im, interchange numerator and denominator. Vm by Im equal to 1 by omega c. So Vm by Im, the ratio voltage by current which gives resistance according to Ohm's law. So V equal to IR. So now R equal to Vy. So R equal to Vy. The ratio Vy which gives resistance. So now here Vm by Im is capacitive reactance. Vm by Im, the ratio which gives capacitive reactance. Capacitive reactance, the symbol Xc. Vm by Im. So Vm by Im, the ratio voltage by current. The ratio which gives capacitive reactance. Capacitive reactance symbol Xc. Xc equal to 1 by omega c. So Xc is known as capacitive reactance. The alternating voltage applied a pure capacitor. What kind of reactance takes place? Capacitive reactance. So here the ratio Vm by Im, voltage by current, which gives capacitive reactance. Capacitive reactance, the symbol Xc. Xc equal to 1 by omega c. So now Xc is a capacitive reactance. So Xc equal to 1 by omega. Omega equal to 2 pi f. Omega equal to 2 pi f into c. So omega equal 2 pi by t. Frequency f equals 1 by t. So omega equals 2 pi f. Frequency f equal to 1 by t. So omega equal to 2 pi by t. The frequency f equal to 1 by t. 1 by t written as what? Omega equal to 2 pi f. So now here capacitive reactance equals 1 by 2 pi fc. Xc is the capacitive reactance. F is the frequency of alternating source. C is the capacitance of the capacitor. How capacitive reactance vary with the frequency of alternating applied source? So inversely proportional to. So this is one more question. The last year examination is one more question. How does capacitive reactance vary with the frequency of alternating source? The capacitive reactance is inversely proportional to the frequency of alternating voltage or AC source. This is very important one more question. So frequency of alternating voltage increase. What about capacitive reactance will decrease? So frequency of alternating voltage decrease, capacitive reactance increase. So how they are related? Capacitive reactance and frequency of alternating voltage inversely. Now we have graph. So capacitive reactance versus capacitive reactance symbol capital X, not small x, capital X and indicate C. Xc, this symbol represent capacitive reactance. So V by Vm by Im, Vm by Im, the ratio is the capacitive reactance. So Xc is the capacitive reactance. So Xc taken along the y-axis. Frequency of alternating current taken along the x-axis. So according to this formula, the frequency of alternating voltage increase. What happened? Capacitive reactance decrease. This is a graph. So draw the graph. The capacitive reactance vary with frequency of alternating voltage. So this equation shows that capacitive reactance is inversely proportional to the frequency of the alternating voltage. If the frequency of the alternating voltage increase, what happens? Capacitive reactance decrease. So now friends, this is a 3-mark question. AC circuit containing pure capacitor. How to arrange the questions in examination? A current derived expression for current in AC circuit containing pure capacitor when alternating voltage applied to the capacitor. So one more time, show that a current leads the voltage by an angle pi by 2 the AC circuit containing pure capacitor. Now please prove this formula. Xc equal to 1 by omega C. Xc is a capacitive reactance. Omega is the angular frequency of AC. C is the capacitance of the capacitor. So Xc equal to 1 by 2 pi Fc. Omega equal to 2 pi of C. So capacitive reactance is inversely proportional to the frequency of alternating voltage. Now this is a graph. Capacitive reactance versus frequency. Frequency increase, capacitive reactance decreases.